Take a look at this workflow. If you have ever tried to animate a wave-like motion by manually keyframing dozens of individual shapes, you already know the eye-straining reality of staring at a chaotic sea of tiny dots. Think of your shapes like musicians in an orchestra. If you instruct every musician to play the exact same note at the exact same time, the result is boring and robotic. But if you tell them to play completely random notes, you just get noise. Professional motion design lives in the sweet spot between those two extremes. The goal is coordinated, organic chaos. To achieve that, we are going to build a master slider rig. Over the next few minutes, you will learn how to automate complex motion using a technique called phase propagation. Moving away from manual keyframes and toward procedural systems changes the way you approach complex scenes. You stop managing individual pixels and start building the logic that moves them. Step 1 is setting up your ecosystem. Start by drawing multiple basic shapes. Let's use 5 circles within a single shape layer. This UI mockup shows exactly how to organize them. Put each circle into its own numbered group within the master layer. Imagine putting dancers in a room and handing each a numbered name tag. The software needs to know exactly who is who. This strict hierarchical organization is the critical foundation of procedural animation. Without these grouped labels, the underlying math has no targets to lock onto. Now we add the engine. Go to the Contents menu and apply the Wiggle Transform operator. Set your baseline parameters to 2.0 wiggles per second and 100 pixels of position. Look closely at this layer hierarchy. The most common point of failure happens right here. The wiggle transform must be dragged down past all your shape groups, so it sits at the very bottom of the contents list. With the engine running, your baseline result will look very rigid. Every single shape will jump together in exact unison, acting like robotic clones. That raw computational power is useless on its own. To get organic movement, we need an intelligent offset system. To build that system, create a new null object in your timeline and name it Controller. This will act as the big brain of your rig. Next, apply 2 expression control sliders to this new null object. Name the first slider Phase Delay and the second slider Spatial Variation. Centralizing your controls onto an invisible null layer protects your underlying math from accidental edits. It also gives you a clean, single-point interface so you can iterate rapidly. Let's wire the brain to the engine. Open your Wiggle Transform properties and Alt-click the stopwatch for temporal phase. This layout breaks down the expression code we are going to write. The first concept is defining a variable called delay, which you create simply by pick-whipping your phase delay slider. The second concept is using a command called property index. This tells the computer to read those numbered name tags we made earlier, determining each shape's rank. Finally, we multiply our delay slider by the shape's index rank. Because of this math, dancer number 2 automatically executes their move slightly later than dancer number 1. This specific equation replaces hundreds of manual keyframes with a single scalable rule. We are forcing the software to do the heavy lifting for us. Before we finish the rig, we need to correct a common piece of bad advice. Many tutorials tell you to alter the random seed for motion variety. Do not do this. This 3D wireframe terrain map represents the noise field, dictating how your shapes move. Changing the random seed teleports shapes to completely different continents, moving chaotically. Instead, shift the spatial phase. Watch the dots spread out on the same slope, maintaining their correlation. Choosing spatial phase over random seed ensures your objects move as a collective unit. It provides a structural variety that feels organic rather than chaotic. To complete the rig, use the exact same expression logic we just wrote, but this time link the spatial phase property to your spatial variation slider. Now, grab your master sliders on the controller layer and dial the values up. Just look at this generated motion. Your rigid, robotic jumping instantly transforms into a flowing, wave-like animation. Now that the foundation is built, try pushing the limits of the rig. Apply these exact same phase expressions to your scale or rotation properties and watch how the system scales. Mastering phase propagation gives you a reliable way to create organic motion across any number of layers. It turns a tedious manual process into a single synchronized workflow.